All right, everybody, and welcome to our solar features section. We'll be talking about coronal holes in depth a little bit today and referring you to a great article, showing you some great imagery and more. Let's blast through it. First, some magnetic data here from the National Sunspot Observatory. This primarily ground-based data consists of magnetometers on 51 ground-based solar magnetometers, as well as ones on stereo A at Lagrange 5 and stereo B at Lagrange 4. Earth is in a North Pole current sheet. No changes expected to come to that anytime soon. We'll keep you posted if they do. Here's the GOES magnetometers over the past 3 days. And we were expecting a coronal hole wind stream there, at least NOAA was, and we never really saw the arrival of that. Pretty smooth readings there on the GOES magnetometers. Here's a line of sight plot. And you can see the shape of the heliospheric current sheet here and its polarity. South pole shown in red, North Pole shown in green. Pretty low levels of solar activity at the moment. And we're going to be talking coronal holes here in a minute. First, the current last few days, the last 4 days of coronal hole activity. And you can see quite a bit of North Pole oriented coronal hole here in the Earth-facing zone. So those green areas there, those are all North Pole-oriented coronal holes, folks. As solar cycle 25 takes its good old time progressing, you can see the South Pole starting to make its migration toward the north as the solar polar fields are in the process of reversing. It happens every solar cycle. And let's talk about this great article here. So coronal holes were not known about until the 1970s. I just researched this morning. I thought it wasn't until the 90s, but indeed Skylab was noting coronal holes. And the interesting part about coronal holes is that they're not really visible from Earth. You got to be in space to see coronal holes, as the ultraviolet light spectra required to notice them does not make it all the way to the surface of the planet. Coronal holes are dark in X-ray and especially in certain bands of the ultraviolet spectrum, such as 193 angstroms, a common wavelength that we show regularly on the channel. We'll be showing you it here in a moment. So this is just a fantastic article here, and we'll show you the URL here in a minute. I just want to scroll up through some of the great imagery here from Skylab. So again, ultraviolet light, at least the spectra required to see coronal holes, doesn't penetrate the Earth's atmosphere. So they're not visible from the planet. You can only see them from space. And of course, the SDO doing a fine job of showing them now. Coronal holes are also like low pressure systems. And the interesting thing about a low pressure system on the sun is that stars are so rowdy that a solar low pressure system emits solar protons out into the greater solar system. So these things are always blasting out solar protons, primarily hydrogen nuclei, charged particles, ions, blasting out of those coronal hole areas. And it's sort of the main feature besides sunspots. So we see also prominences. Those are just plasma suspended in the solar corona. But the main features really on the sun are the coronal holes and sunspots. Coronal holes give us insight into the solar polar field reversal process. And let's just show the URL for this. The article here is titled The Quiet Sun, SP402, A New Sun, The Solar Results from Skylab. And this is on the history.nasa.gov series of web pages. So check that out if you like. And here's the current state of affairs when it comes to coronal holes with the closest star. You can see those North Pole-oriented ones there just moving past the earthly zone. And those are pretty huge. We've put up a 211 angstroms video here as well, just to show you the Earth scale and the size of that North Pole-oriented coronal hole. We can expect a solar wind stream from that in a couple days. Also some great filamentary activity up there. This filament up here is starting to look a bit unstable. See our previous space weather video that we premiered just before this one to see more about that. Next, we'll move on to sunspots. And we're going to be down to only one named sunspot group, it certainly looks like at the moment. This sunspot over here is just about to set. This is 24 hours, by the way. And this one here, which is, I believe it's 2934, is a simple sunspot, the likelihood of large flares just simply not there. So again, likelihood of large flares not there at the moment. And we're dropping down to only one sunspot group here. Low levels of solar activity. That's why we decided to cover coronal holes on today's video. Next, we'll blast through some more data here. The X-ray flux looking pretty quiet over the past 3 days. No major flares, not even a C-class intensification over the past 3 days. Proton flux still subsiding here following that M5.5 flare. That did send some relativistic particles. That only took about 40 minutes to get to Earth. Now they're subsiding. Radio blackouts also no longer happening. So looking at the real-time solar wind here, we see a relaxation of a higher speed wind regime. Solar wind now about 360 kilometers per second. Solar wind density only about 5.8 protons per cubic centimeter. The rest of the panes there, fairly unremarkable. KP index, a measurement of global geomagnetism, only at 2. Geomagnetic calm conditions. Let's take a look at the geospace magnetosphere movie here. Earth's magnetic moment from space out to about 12 Earth diameters. I would anticipate a slight reduction here in the magnetohydrodynamic pressure. The scale you're looking at here is nanopascals. Again, magnetohydrodynamic pressure. And this is 4 hours of video. And again, you can see that small subsiding there of the pressure as Earth's geospace returns back to a level of static equilibrium here. Now we're looking at ground magnetic perturbations, also 4 hours. Geospace delta B changes to Earth's B field. The scale here is nanotesla magnetic flux density, again from the surface of the planet. This one's good at showing where the likelihood of aurorae and large amounts of induction into the power grid and so forth. Next, our astronomy picture of the day from Cassini. Fantastic imagery here of course, Saturn and Tethys, one of the Saturnian moons. The shadowy environment of the Saturn ring system and the moon Tethys. Fantastic imagery there. Absolutely surreal. Imagine being there when that was taken. It's pretty far away and pretty cold. Keep in mind this solar system diagram is not to scale. We're just showing this to show a 1-week forecast of what's going on in the solar system. Mercury's making its way past. Here's where things will be in 7 days. A crescent waning as we approach another new moon at the end of January into February. If you're up before dawn, you might see Mars and Venus rising ahead of the sun. That's our star chart from in-the-sky.org. And last but not least, we do have a minor coronal mass ejection to show here. Some minor portion of this might strike Earth, but it's not significant. The entire thing might miss. I think a tiny bit might show up. We may see a small signal. Most of that is directed towards stereo A, as you can see this halo. So if you saw this sort of a halo from the LASCO C3, you can see it's mainly off to the left. However, from the perspective of stereo A is going to get quite a bit of this ejecta. Again, if any of that does strike Earth, it'll be pretty minor. For you new viewers out there, stereo A is located at Lagrange point 5 here, trailing the Earth orbitally speaking. The LASCO C3 would put the Earth behind you. From stereo A, the Earth would be off to stereo A's right. So thanks for tuning into our solar features section. We hope you enjoyed the stuff about coronal holes. Feel free to go read that article on the NASA site. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-a-Mash, once again signing off from the Smash News Network, least busted name in news.